In this video, we are going to be looking at circle geometry, and we are going to be looking at some exam type questions. So here I have my first question. So we are going to use the geometrical properties of a circle to give reasons for each step of our answer, and we want to determine the measure of angle SPQ. So that's S to P to Q. That's this angle right in here. And also we want to find the measure of the angle OQS. So O to Q to S. So that's this angle in here. So let's start with the first one, angle SPQ. So the vertex of the angle is at the letter in the middle, which is at P. And the arms of the angle is S to P and P to Q. So that's S to P and P to Q. Vertex is at P. And that's why the angle is located here. Now if we look carefully, what we have here from S to R to Q to P and back to S, that will be a cyclic quadrilateral because all four vertices touch the circumference of the circle. And we know that the opposite angles of a cyclic quadrilateral are supplementary. So 58 plus this angle here, SPQ, must add up to 180 degrees. So I'll have angle SPQ plus the 58 degrees is equal to 180 degrees. So I'll simply transfer this positive 58 degrees across the right hand side and will turn to negative 58 degrees. So I'll have angle SPQ is equal to 180 degrees. Take away 58 degrees. So I'll have angle SPQ will be equal to 122 degrees. Now your reason would be that the opposite angles of a cyclic quadrilateral are supplementary. But we could shorten that and just simply write opposite angles are supplementary. So here I have my reason. OPP full stop is for opposite. This angle symbol with the apostrophe S means angles. And SUPP full stop means supplementary. So opposite angles supplementary. Now let's look at part 2 where we want to find the measure of angle OQS. So the vertex of the angle is at Q. OQ is an arm and QS is the other arm. So OQ is an arm and QS is the other arm. And the vertex is at Q. That's why this is the angle we want to find the measure of. Now first of all, I notice that the angle at O, that angle is SOQ, is the angle at the center of the circle and stands on the chord QS or SQ. And also this angle up here at R, which is angle SRQ, it also stands on the chord SQ. And this angle is at the circumference of the circle. And we know that the angle at the center of the circle is twice the angle at the circumference of the circle. So I'll write that angle SOQ, so that's this angle here, is equal to 2 times angle SRQ. And angle SRQ is this angle right here. So that's equal to 2 times 58 degrees. So that will be 116 degrees. And my reason for doing this working would be that the angle at the center of the circle is twice the angle at the circumference of the circle. And of course, those 2 angles must stand on the same chord or arc. So I wrote my reason as angle at center is equal to 2 times angle at circumference. Now next, I notice that the length of the line SO and the length of the line OQ are equal because they are the radii of the circle. So I'll write SO is equal to OQ. And my reason for that would be radii. Now that I know that these 2 sides are equal, then this triangle SOQ would be an isosceles triangle. Therefore, the base angles of an isosceles triangle are equal. And this angle SQO that we want to find the measure of is one of the base angles of that isosceles triangle. We also know that the sum of the interior angles of a triangle must add up to 180 degrees. So first I'll say that angle OSQ is equal to angle OQS. So that's saying that these two angles are equal. And the reason for that would be that the base angles of an isosceles triangle are equal. So here I have my reason as the base angles of an isosceles triangle are equal. So now angle OSQ, which is this angle here, plus angle SQO, which is this angle here, plus this 116 degrees, must add up to 180 degrees because the sum of the interior angles of a triangle is 180 degrees. So I'll write angle OQS, which is this angle here, plus angle OSQ, which is this angle here, plus the 116 degrees is equal to 180 degrees. Now we know that angle OSQ and angle OQS are equal to each other. So we can replace this OSQ with OQS. So here I've replaced the angle OSQ with angle OQS because OSQ is equal to OQS. So now OQS plus OQS will be 2OQS. So I'll have 2 times OQS plus 116 degrees is equal to 180 degrees. So now I'll transfer this positive 116 degrees across the right hand side and it will turn to negative 116 degrees. So I'll have 2OQS is equal to 180 degrees, take away 116 degrees. So I'll have 2OQS is equal to 64 degrees. So now we can simply divide both sides of the equal sign by 2 to get angle OQS. Or we can say we transfer the 2 across the right hand side and the operation changes from multiplication to division. So the 2 will go under the 64. So now I'll have 64 divided by 2, which is 32 degrees. And my reason for this working would be that the sum of the interior angles of a triangle is equal to 180 degrees. So my reason would be that the sum of the interior angles of a triangle is equal to 180 degrees. So here I have my next question where we want to determine, giving reasons for our answer, the angle ABC. So that's A to B to C. So that's this angle right here. So let's deal with finding this angle first. Now what I notice is that this line from A to B passes through the center of the circle. So this line is the diameter. Therefore this angle at the circumference here would be the angle in a semicircle. So this would be a 90-degree angle. And the reason for putting this 90-degree angle here is because angle in a semicircle is equal to 90 degrees. So the arms of the angle stands on the diameter and the angle is at the circumference of the circle. So I'm going to say angle ACB is equal to 90 degrees. And my reason for that would be angle in a semicircle. So now I have triangle ABC and the 3 interior angles must add up to 180 degrees. So 58 plus 90 plus this angle ABC, that's this angle right here, must add up to 180 degrees. So I'll have angle ABC, which is the angle they want us to find, plus 90 degrees plus 58 degrees is equal to 180 degrees. So 90 plus 58 is 148 degrees. So now I'll transfer this positive 148 degrees across to the right hand side and it will turn to negative 148 degrees. So I'll have angle ABC is equal to 180 degrees, take away 148 degrees. So angle ABC is equal to 32 degrees. And my reason for doing this working would be that the sum of the interior angles of a triangle is equal to 180 degrees. So part 2, they want us to find the magnitude of angle CMB. So that's C to M to B. So that's this angle right here. So what I'm noticing about finding this angle CMB, which is this angle here, is that what we have is a cyclic quadrilateral, a 4-sided shape where all 4 vertices touch the circumference of the circle. And therefore the opposite angles of a cyclic quadrilateral are supplementary. So for part 2, I'll have angle CMB plus 58 degrees is equal to 180 degrees. And that's because this 58 degrees is opposite to angle CMB. And this is a cyclic quadrilateral. So I'll transfer this positive 58 degrees across to the right hand side. I will turn to negative 58 degrees. So I'll have angle CMB is equal to 180 degrees. Take away 58 degrees. And I'll get 122 degrees. And my reason for this working would be that the opposite angles of a cyclic quadrilateral are supplementary. So I'll simply write for my reason that opposite angles supplementary. Now part 3 of my question will be to find the magnitude of angle NCM. So that's N to C to M. So that's this angle right here. Now to find this angle here, what I notice is that this is a straight angle here. This 122 degrees that we found here, and this angle CMN would form a straight angle. So therefore I can get this angle here, and then I can see the sum of the interior angles of this small triangle would add up to 180 degrees. And that's how I'll be able to find the angle NCM, this angle here. So first I'll say that this 122 degrees plus angle CMN must equal to 180 degrees. So angle CMN plus 122 degrees is equal to 180 degrees. So when I transfer this positive 122 degrees to the right hand side, it will turn negative 122 degrees. So I'll have angle CMN is equal to 180 degrees. Take away 122 degrees. So I'll have angle CMN is equal to 58 degrees. And my reason for that would be a straight angle. So now I have that this 90 degrees plus this 58 degrees plus this angle NCM, which is the angle we want to find, must add up to 180 degrees. So I'll have angle NCM plus 58 degrees plus 90 degrees is equal to 180 degrees. So 58 degrees plus 90 degrees is 148 degrees. And now I'll transfer this positive 148 degrees across the right hand side. I will turn negative 148 degrees. So I'll have angle NCM is equal to 180 degrees. Take away 148 degrees, which is equal to 32 degrees. So here I have my reason that the sum of the interior angles of a triangle is equal to 180 degrees. So that will be my reason for doing this working, adding up all these three angles and putting it equal to 180 degrees. So here I have another question, and we want to calculate the value of each of the following angles. I want to show detailed working and give a reason to support our answers. So our first angle we want to find is angle DBA. So that's angle D to B to A. So that's this angle right here. So what I notice is that this line AC passes through the center of the circle. So this line AC is the diameter of the circle. Now this angle B is at the circumference of the circle, and the arms of this angle AB and BC stands on the diameter. Therefore, this angle at B, angle ABC, is the angle in a semicircle, which is equal to 90 degrees. So therefore, this 46 degrees and this angle DBA, which is this angle here, would be complementary angles. But first, I'll have to give my reason for saying that this angle here is 90 degrees. So for part A, I'll have angle ABC is equal to 90 degrees. And my reason would be angle in a semicircle. So now that I have my reason for putting this 90-degree angle here, now I can say that these two angles here are complementary. So I'll have angle DBA plus 46 degrees is equal to 90 degrees. So I'll transfer this positive 46 degrees across the right hand side. I will turn to negative 46 degrees. So I'll have angle DBA is equal to 90 degrees, take away 46 degrees. So angle DBA is equal to 44 degrees. And my reason would be complementary angles. And complementary angles would mean two angles that add up to 90 degrees. So for part B, we're going to find the angle DAC. So that's D to A to C. So that's this angle right here. So what I notice here is that this angle DAC, that's this angle here, stands on this chord DC. And angle DAC touches the circumference of the circle. Now what I also notice is that the angle DBC, which is 46 degrees here, also stands on the same chord, DC, and also touches the circumference of the circle. Therefore, these two angles will be in the same segment, and angles in the same segment are equal. So for part B, I'll have angle DAC is equal to angle DBC. So I'm saying that angle DAC, this angle here, is equal to angle DBC, that's this angle here. So we know angle DBC is equal to 46 degrees. And my reason would be that angles in the same segment are equal. So I could simply write for short angles in the same segment. And now for part C, we want to calculate the value of the angle BCE. So that's angle B to C to E. That will be this angle right here. Now for this question, what I notice, I have a cyclic quadrilateral because I have a four-sided shape from D to A to B to C back to D. And all four vertices touch the circumference of the circle. So that's a cyclic quadrilateral. Now this angle BCE is the exterior angle for this cyclic quadrilateral. And I know that the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. So this angle here would be the interior angle, and opposite to that would be this angle here at A, which will be 28 plus 46. So this interior opposite angle is equal to this exterior angle out here. So for part C, I'll have that angle BCE is equal to 46 degrees plus 28 degrees. So I get that angle BCE is equal to 74 degrees. And so my reason would be the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle.